Yes,
Hello?
ma'am, I can hear you. You may start, I said.
Okay, thank you so much, Mr. Potterden. Good afternoon, listeners and colleagues. As you know that we were still busy with numeric and geometric pattern. So today we're going to proceed with numeric and geometric patterns. So remember, we must know why do we do the numeric and geometric patterns. But I think with numeric patterns, I've already touched on it. So today I'm going to clarify on geometric patterns. And for geometric patterns, they provide us with the sense of order and balancing. That means when you are creating some shape, it helps you to have the sense of putting things in order and balancing them. It also helps you to understand the geometric shapes, the principles, and the relationships. It also it helps you to locate the different objects and understand the relationship between those two different objects. It can also provide you with the skill to plan, the skill to design the space, and to make the accurate calculations for various practical tasks. Okay. Then we have already talked about why are we learning the geometric patterns. So we learn geometric patterns because mathematics is a real life related subject. We almost do maths in everything that we are doing in our lives. As you can see here, I have placed the picture of this shape, which is called Titana in Sesotho. It is the object that is used to be worn by the Lesotho girls, but we are not. That one is not our main focus. Our main focus here is on the geometric patterns. I want you to understand that geometric patterns, here is the certain arrangement. Here we have the white color, the orangey color, the blue color. Can you see that those colors are placed white, orangey, and blue? And then it is white, and this one is lime, and then it's white. And then we have what again? We have orangey, blue, white, and lime. So that means as a learner, you must understand this arrangement of the pattern. As you can see here, in the middle here, now it is where the shape of this from this side and from this side where they meet. Then this order, you must understand it by using what? The geometric patterns that we did prior. So that skill is going to help you in real life to produce this kind of objects in real life. We have started with this part. So we can also maybe, let's come to this side where we have this blue. Maybe I can change the color of the pen so that you can see. Let me take purple one. And then I want to erase this one. Okay. So let me take this one. You can see the outside part. It is also having its own arrangement that you must be careful of. Here is the blue one. We have red. We have another, I think this one is navy blue. We have red. We also have yellow here. But you must understand this pattern so that you can be able to design another pattern. Let's say, for example, the question says this object is for the child of 5 years maybe. So if the question says design the very same shape for a 10-year child, you must be able to do so by understanding what is happening on this pattern. So I think I made myself clear. You must understand how there is the arrangement, how did they placed, and then what will you do when you do for the next person. Okay, we also have this one, the Sesotho head. As you can see, the Sesotho head, this one I think is the big one. So as a learner who did mathematics, when the question says, let's say this one is for an adult, this head is for an adult. So that means you must understand how this the strings here have been arranged. How many are they? You will count how many are there and how many lines here. That means you understand what it is. It takes you to where you will get the constant difference. It will lead you to the constant difference. So if you understand the constant difference, then you will be able to do what? If you understand the constant difference, that means you'll be able to find or to formulate. You'll be able to formulate your rule, which is the promise I did yesterday, that today we're going to focus more on generating the rule. So this rule will help you to produce the different types of the heads with different shapes or different sizes, but it will depend on the instruction that is given. So if this one, it says maybe it's for adult who is 15 years or 20 years, you will use your general rule to substitute this 15 so that you can get the proper way of following your composing of the head, if it is now no longer for an adult. So in short here, my dear learners, as you can see what I've already done here, if you have learned number pattern at school, there's no reason for you to be poor, because you can make business. You are now professionals. Professionals. You can do this better. I think we can move on to the next slide. Like this one, the Sesotho head, you can come up with the new design of your own that Lesotho people or people from Free State can appreciate this, and then you'll have your business as a successful businesswoman or business man. Here I have the grass mat. This grass mat is having the small lines and the big lines. You see, these ones are the big ones, but here in the middle we have these ones. We have these ones again. We have these ones. We have these ones, we have these ones. So you must understand the pattern. If you can check this side, we have how many small lines? We have 1, 2, 3, 4. But if you go on, we don't count this one because this one is just separating. We have what? How many lines? 1, 2, 3, 4, 5. And we also have 1, 2, 3, 4, 5. And again, we also have 1, 2, 3, 4, 5. But with this one, it's the same as that one. So these two are the same. They are not having 5 strips and 5 lines. They have how many? 1, 2, 3, and 4. So it is very wise for you, my dear learners, to understand the pattern first, so that you can be able to design your own. So if you have this pattern, you got this arrangement, it will be easy for you to design your own mat. That is how the geometric patterns are helping us in real life. You can design your own mat, or you can design your own tablecloth, or anything. But remember here, you are using what? You are using your geometric pattern skills. I also have this one, which is a Zulu mat. This is the pattern that we already have. But like I have mentioned, you as current math learners, you can come up with something that is new, but you must understand the pattern. As you can see here on this mat, the pattern on this side is the same as the pattern on this side, but this one is different. So you can see that you have what? You have one V here, and you have one V, and you have two, what is it? Is it rhombus or a square? You have these kinds of two shapes. But again, in the middle, you have what? You have a square. You have a square and also there. So you must understand this pattern so that when you design your own, you know that I'm going to start with V first, and then I will do the rhombus or the square, two squares in the middle, so that when the question says design for the big mat, maybe you can do the doubling of the dices of the, what is it, of the squares or the rhombus. Maybe you can have 4 of them, and you can have this one as the closing shapes. It's the closing shapes. So I think with this one, I will just stop there. I wanted to bring your attention, to bring your minds in real life situation, so that we are not doing these geometric shapes for fun or just for us to have marks, but they are there in life. We have them in real life. So I think some of you can come up with many ideas here that, ma'am, I can identify that maybe this line, what is happening with this line? Someone can explain what is happening with this line, but there are many things that we must understand. We must understand how is it arranged, the order, the color. Here is pink. You can see that here is pink, but here is orange. So you must follow the proper arrangement. You place them in the correct order so that you can be able to get what? The constant difference and what? And the general rule. So for us to have the basic foundation on what do we need for making the correct design. I mean, on the geometric shapes, I've already mentioned before that we need to get what? Our constant difference, and must be able to formulate what? The correct general rule. So if you can identify the constant difference, but your general rule is wrong, that means you are going to get what? Your wrong shapes. The shapes will be wrong. You will get the wrong shapes. So make sure that you check the geometric pattern or the numeric pattern thoroughly so that you get the correct constant difference, and make sure that you follow proper procedure to get the general rule. So I want us to make sure that we maintain the accuracy in obtaining the correct general rule, especially when we are working with the constant ratio. Remember, I said to you the geometric patterns and numeric patterns are one and the same thing. It's just that sometimes I will write 2, 4, and 6 for numeric patterns. But if it is something like a shape, I can write 2 matchsticks, maybe. 2 matchsticks, maybe for the next one, it will be 4 matchsticks. And then for the next one, I don't know how to put it, but it will be 6 matchsticks. So that is how it is all about. It's all about numbers, but here we are dealing with shapes. Okay, so don't be confused when you are given the shapes, and then they say to you, find the general rule of the shapes. You are going just to check for the constant difference. You check for constant difference, and what else? And you formulate your general rule. I will show you how to formulate the general rules. I'm going to show you, but I think before I can show you, I have summarized here Here are the points on how to obtain the correct general rule. You must know the position of the term in the sequence or the pattern. Remember, we said sequence and the pattern are one and the same thing. So make sure that you understand the positions so that you write term number 1. These are the positions. Term number 3. Okay, then you find the constant difference of the sequence. Here, it is where you assess the given pattern. You check what is happening on the given pattern, and then you decide whether you have a constant difference or you have the constant ratio. After that, you multiply the constant difference with the position of the term. That means, let's say here, you did find your constant difference as 2. Okay. I'm sorry for that. We'll go back to our slides. Let's say here you have managed to get your constant difference as 2. Let's say your constant difference is 2. Then we say for the third step, you are going to say a constant difference multiplied by the position number. That means you will say 2 multiplied by 1 for position number 1. But for position number 2, you're also going to say 2 multiplied by 2. Then the answers here will be 2, and here it will be 4. So this is how I'm going to deal with it for the third step. Then the first step, you find out what will you do. What will you do to obtain to get the original values? So now you have these 2 and 4. Let's say your original values were 1, maybe, and 3. Then if you have 1, 3, 5, then the question, this point, it means that you will say from 2, what am I going to do to get 1? That means I will say 2 minus 1. From 4, what am I going to say to get 3? That means I'm going to get minus 1. So that means I will say 2 minus 1, it will give me 1. And then I will say 4 minus 1, it will give me 3. So this is how we are going to work it. And then let us go to the table. Let us go to the next slide where, let's say, it will be like this. But here you can see that the constant difference is 2. We said constant difference is 2, but here we have 2 by n. We'll have the column where we have n. Then that means here is going to give you 2n. Then 2n minus 1 is going to be like this, 2n minus 1. That is where you will say, this is my general rule. But let us go to them. I've prepared the next slide. I think my screen is giving me a challenge now. Okay, here it is. It's fine now. I'll manage to go to the next slide. Here you have what? You have 5, 8, 11, and 14. Then as a learner, you will check from 5 to 8, what has happened? That means we have said 5 plus 3, which is 8. We said plus 3. And then what has happened here? We have 8 plus 3, which is 11. 11 plus 3, which is 14. So I like this method of table. I'm really in love with this method of table, where you will write first the position of the term. Position of the term. That is why I said you will write term number 1, term number 2, term number 3, 1, 2, 3, 4. We have term number 4, and then the Tn. Then you check your constant difference. Your constant difference multiplied by your position. Then you will say 2 multiplied by 1, which is 2. Then for the second one, you say 2 multiply by 2, which will give you 4. For term number 3, you will say 2 into 3, which is 6. 2 into 4, which is 8. Then on this side, you will say 2 multiplied by n. As you can see that we wrote 1, 8, 1, 2, 3, and 4. This one is here. This 2 is here. This 3 is here. Can you see that? 4, 4. And then that means on this side, we must multiply by n. And then from that, we go to the third step. What do we do? What do we do to get the original? What do we do to get original ones? To get original values. Original values, okay? So for you to get 5, you have 2 here. For you to get 5, what are you going to do? You will say plus 3. You have 4 here. No, let us erase this one, I think. We have mistake here. I need eraser. Let me clean this one. Okay, we say what do we need to do to get the original number? That means we must obtain 5, 8, 11, and 40. So we check. Okay, I think there is some mistake here. Our general rule is not 2, it's 3. Our general rule is not 2, but it is 3. Let us rectify it, my dear learners, using the red pen. Our general rule here is 3. 3, not 2. 3, 3, 3. Remember, we said it here. The constant difference. Then we say the constant difference must multiply by the position of the term. So here is the constant difference multiplied by the position of the term. That means here is going to be 3. Remember, we focus on the red pen. Then we say 3 by 2 is going to give us 6. And then we say, what is it here?
Ma'am, you will have to wrap up. You're long over your time already.
Is it over, sir? Mr. Paul?
Yes, ma'am. It's you've been 7 minutes over your time already. The other presenters are waiting to present. Please wrap up.
Okay, let me skip this one if it's taking time. I have this one that I've done it alone, but I think using that explanation I did before, it will be easy for them to understand. I wanted to do it together with them, but it's fine. I think here we have term number 1, term 2, term 3, and term number 4. Here again. And then we wrote Tn. Then remember we said you check the constant difference multiplied by the position. Then here our constant difference, we can see that it is 4. Then we say 4 multiplied by 1. Here it is 4 by 1. And then 4 by 2, 4 by 3, 4 by 4, and 4 by n. And then we check. We have 10 as the term number 1. So we have 4. What are we going to do between 4 to get 10? Then we'll add 6. Then 4 plus 10 is going to give us 6. That means all of them we are going to add 6. So here we have what? We have 4n, n plus 6. That means here our answer will be 4n plus 6. I think there is the typing error here. And I'm sorry for that. Here is going to be 4n plus 6. That is how it's going to look like. This will be your general rule. So let us consider this one. I think this one maybe they will take us long. Let me go to the work example. Even though I wanted us to work with them together, but it seems like it is taking us time. So this one is of the constant ratio, where you check that between here, you are not getting the constant difference. That means you get, it says you have multiplied by -3. 3. When you say 4 by negative 3, it will give you negative 12. Negative 12 by negative 3 is going to give you negative 36. So your constant ratio is going to be negative 3. So we have this general rule where to find our general term when we work with the constant ratios. Then we will say 4, it is written as Tn is equals to term number 1 multiplied by the constant ratio, exponent n minus 1. Then remember, you have the one that we have worked with before of the constant ratio is written as Tn is equals to, we normally write it as Dn plus C maybe, but it must look like this. If it is for the constant difference. So this one is for the constant ratio. So I think this is the end of my presentation, my dear learners and colleagues. I don't know if I still have time, Mr. Paul.
Thank you very much, ma'am. Yes, ma'am. Thank you very
Thank
much.
you.
You can stop sharing so that the next person can start. Thank you very much.
Thank you so much. Right.
I just want to check that everybody can hear me and also see the slides.
I can hear you, Eileen. You may start.
Okay, I'm just going
see your
to do the
slides.
record quickly. Let me see that I do. It is recording.
Not there. I'll start recording for you quickly.
Okay, thank you very much. All right. Okay, good afternoon, everyone. I just want to get this.